Okay, students, how are you? I'm fine. Uh, Today we are going to uh, learn about uncertainty in measurements. Uh, what does it mean when we say uncertainty? What does it mean? First, how it is happened. How it is happened when we try to measure something, and also how to reduce this uncertainty. So today we learn this. We are going to see this. Follow me. Okay, let us start. Okay, the topic says what? Uncertainty. Uncertainty in a measurement is how much the measured value is likely to deviate from the unknown true value of the quantity. You know, the true value, that means the exact value of, for example, when we try to measure something that has that has an accurate value or exact value. So when we say uncertainty, it is what? Measured value that is deviate from the unknown true value. The unknown true value. The deviation is called what? Uncertainty. When we say this measurement is uncertain, when we say it is uncertain, it is what? It deviates from the truth value. Okay, so uncertainty in a measurement is how much the measured value is likely to deviate from the unknown true value of the quantity. Uncertainty indicates a doubt about how well the result of the measurement presents the value of the quantity being measured. Yeah, it indicates a doubt about how well the result of the measurement presents the value of the quantity being measured. So when we say uncertainty, we are talking about deviation, we are talking about doubt, we are talking about error. Uncertainty referred as an error in the measurement. Yeah, uncertainty referred as an error in the measurement. Errors divide into two. When we say error, they fall into two: systematic error and random error. So let us see what does it mean let us see one by one. Systematic error resulting from measuring device being out of calibration. Systematic error is errors resulting from measuring devices being out of calibration. For example, if we use one measuring device, but if we do not check, or if we do not calibrate it, if we do not calibrate that device every 6 months, systematic error may happen. So this calibration means what? Calibration means comparing the measuring device with a standard one and try to correct it if there is an error, or if there is deviation. If that device has a problem, we have to check every 6 months according to the calibration rule. This is what we learn in metrology. Metrology, as you know, it is branch of physics which study about the measurement. Metrology is science of measurement by itself. When we say metrology, it is science of measurement. So calibration is when we say calibration, it is what? Correcting a device every 6 months. So if we do not calibrate each measuring device every 6 months, what happen? There may be systematic error happen. So to correct this systematic error, is corrected by pre-calibration against a non-trusted standard. Pre-calibration means, or pre-calibrating means what? First, calibrating the measuring device. Before measuring something, we have to calibrate the device by itself with a standard one. The second one is random error. Okay, for example, this systematic error, for example, beam balance. If we use beam balance for many years without calibration, there may be a systematic error happened on that beam balance. The second one is random errors. Random errors is error resulting in the fluctuation of measurement of the same quantity about the average. This is what resulting in the fluctuation of measurement. There is fluctuation of measurement here. When it's a random error, it is a fluctuation error resulting in the fluctuation of measurement. Generally, these random errors result from the fineness of scale division of measuring device. Okay, this is what different from systematic error. It is what fluctuation of measurement of same about the average. That means, for example, meter stick to measure a length 1 meter, 2 meters, 2 meter and a half. For example, that is what? If there is fluctuation, we fall into random error. That is happened by the scale division. Scale division may be one small, one large. So the fluctuation measurement, for example, like meter stick to measure a length, that is fall in random errors. Systematic errors are generally simple to analyze. Systematic errors are generally simple to analyze. Yeah, it is. If you calibrate it, it may be corrected. But random error requires careful analysis. Random error requires what? Careful analysis. So let us see. Okay, there are statistical method for calculating random uncertainties in measurements. General rules used to determine the uncertainty using a scale or digital measuring device. Using a scale or digital measuring device. Uncertainty in a scale measuring device is equal to the smallest increment divided by 2. Here we have two rules. General rule used to determine the uncertainty using a scale and digital measuring device. Let us see the first one. Uncertainty in a scale. Uncertainty in a scale measuring device is equal to the smallest increment divided by 2. Uncertainty of the scale measuring device, smallest increment divided by 2. For example, meter stick, that is considered as a scale device. So uncertainty for the scale device equals to the smallest increment. What is the smallest increment of a scale? 1 millimeter. The smallest increment is 1 millimeter. So we have to divide the smallest increment, 1 millimeter divided by 2, 0.5 millimeter. Which means when we convert this 0.5 millimeter to centimeter, is 0.05 centimeter. You know 1 meter is equal with 100 centimeter, and which is equals to 1 meter is equals to 100 centimeter is equals to 1000 millimeter. You have to know this relation. You have to know 1 meter is equals to 100 centimeter is equals to 1000 millimeter. So you have to know these relations for conversion. So what is the smallest increment for the scale division? For the scale measuring device, what is the smallest increment? It is 1 millimeter. So uncertainty is what? 1 millimeter divided by 2 is 0.5 millimeter, which is equal to 0.05 centimeter. The second one is digital case. Uncertainty in a digital marketing. Uncertainty in a digital measuring device is equal to the smallest increment only. No need of dividing by 2 here. Uncertainty in a digital measuring device is equal to the smallest increment for digital measuring. So uncertainty is equal to smallest increment. Example, a reading from digital balance is 5.7513 kilogram. Therefore, what is the uncertainty for this digital measuring? 0.0001. Reading from digital balance is it is considered as digital device. So reading from digital balance or digital device is 5.7513 kilogram. Therefore, this uncertainty of digital measuring is 0.0001. So this is enough for today. We continue in the next class. Thank you.